We're standing today in front of a truly unique aircraft. It's actually, for me personally, quite emotional. For the untrained eye, the viewer don't really see the difference from previous aircraft.
The winner of tomorrow's air combat will be the one that's able to adapt to present circumstances, gets ahead of the enemy, and then can shift and strike from unexpected directions.
Sweden joined NATO in March 2024 after decades of neutrality, and the alliance gained something it did not fully appreciate at the time: access to combat aircraft specifically designed for the operational environment that NATO now considers its most vulnerable frontier, the Arctic. Swedish Gripen fighters have been operating in Arctic conditions for over 2 decades, routinely flying missions in temperatures that would ground other aircraft, launching from improvised strips that most fighters cannot use, and demonstrating operational availability rates that expose fundamental problems with how NATO has been approaching northern defense. These are not theoretical capabilities or marketing claims. These are operational realities documented through years of Swedish Air Force missions defending Arctic territory against Russian probes and incursions. And as NATO members begin seriously planning for Arctic defense scenarios, the performance gap between what Gripen delivers operationally and what American F-35 provides theoretically is becoming impossible to ignore. The operational tempo specifically reveals the difference between design philosophy and actual capability. Swedish Gripen squadrons maintain readiness rates consistently above 90%, even during extended Arctic deployments. The aircraft operates routinely in temperatures reaching -40 degrees Celsius. Engine starts work reliably in extreme cold without requiring specialized heating equipment. Avionics systems function normally despite thermal stress that causes repeated failures in systems designed for temperate climates. Flight control surfaces respond predictably when ice accumulation would compromise aircraft designed without Nordic environmental testing. This is not about one system working better than another in laboratory conditions. This is about aircraft that fly combat missions in the environment where NATO increasingly expects to face Russian challenges, versus aircraft that require extensive support infrastructure to operate at all in those conditions. The F-35 Arctic performance issues are documented in official U.S. military testing reports that are publicly available. Cold weather testing has revealed repeated problems with engine starts requiring preheating equipment. Avionics systems have experienced malfunctions in extreme cold. Stealth coatings degrade when subjected to thermal cycling between Arctic temperatures and operational heating. The aircraft requires climate-controlled maintenance facilities that do not exist at forward Arctic locations where rapid response operations would actually occur. These are not design flaws exactly. These are the inevitable results of designing aircraft for one operational environment and then attempting to adapt them for completely different conditions. The F-35 was optimized for penetrating advanced air defense systems in high-intensity conflicts. It was not designed for sustained operations from austere Arctic bases in extreme cold, defending vast territories against persistent intrusion. The Gripen was designed specifically for exactly those missions, because that is what Sweden needs its Air Force doing. The maintenance and logistics comparison specifically explains why operational availability matters more than peak performance specifications. Gripen maintenance requires 4 technicians using standard tools. A complete engine change can be performed in field conditions by 6 personnel without specialized equipment. The logistics footprint for a deployed Gripen squadron fits in a few trucks. Spare parts are standardized and widely available. Software updates can be performed by squadron maintenance personnel with access to source code rather than requiring proprietary contractor support. The F-35, by contrast, requires extensive maintenance infrastructure, specialized tools for stealth coating work, secure facilities for classified systems maintenance, contractor technical representatives for many repairs, a logistics chain dependent on American supply networks that can be disrupted by political decisions or international crises, for defending Arctic territories where infrastructure is minimal and isolation is routine. The logistics difference is not a marginal advantage. It determines whether aircraft can actually operate forward or must remain tethered to major bases hundreds of kilometers from where they are needed. The dispersed operations capability specifically addresses how modern Arctic defense actually works. Russian strategy relies on overwhelming local forces before NATO can concentrate superior numbers. The counter is distributing forces across multiple locations so that Russian attacks must spread their efforts, while NATO maintains interior lines allowing mutual support. This requires aircraft that can operate from highway strips, improvised bases, and austere locations with minimal warning. Gripen was designed explicitly for this concept. The aircraft lands on shortened runways. It can be refueled and rearmed using standard trucks and portable equipment. Maintenance can be performed without hangars or specialized facilities. Small detachments can operate independently for extended periods. The F-35 requires proper runways, extensive support equipment, and base infrastructure that takes weeks to establish. In scenarios where Russian missiles have destroyed major air bases and NATO must operate from dispersed locations, Gripen continues flying missions while F-35 waits for infrastructure reconstruction or evacuation to intact facilities. The weapons integration reality specifically affects combat capability in ways that specifications do not capture. The Gripen integrates the MBDA Meteor missile operationally today. Meteor provides engagement ranges exceeding 200 kilometers with kinematic performance that maintains high speed throughout the flight profile. The no escape zone, the distance at which targets cannot kinetically outmaneuver the missile, is reportedly 3 times larger than comparable weapons. For Arctic defense missions where Russian bombers and cruise missile carriers must be engaged at maximum range before they release weapons threatening Nordic cities, Meteor range and performance provide the capability that mission requires. The F-35 carries the AIM-120 AMRAAM, which has shorter range and inferior kinematic performance. Meteor integration on F-35 has been discussed for years, but remains blocked by American export control policies and integration timeline delays. The aircraft, with inferior stealth characteristics, carries the superior missile and can engage threats the stealthier aircraft cannot reach. In actual combat, the aircraft that shoots first from longer range has significant advantage regardless of radar signature differences. The cost per flight hour data specifically determines how much actual capability NATO gets from defense spending. Gripen operational costs run approximately $19,000 per flight hour, according to data published by existing operators. F-35 operational costs currently exceed $35,000 per flight hour, based on official U.S. Air Force figures. For maintaining continuous Arctic patrol presence, the cost differential is enormous. A nation flying 2,000 sorties annually for persistent sovereignty operations spends $38 million with Gripen versus $70 million with F-35. Over 30 years, that difference approaches $1 billion per squadron. That money funds additional aircraft, weapons, infrastructure, or other capabilities. The lower operational cost specifically means NATO gets more actual flying hours, more training, more readiness from the same defense budget. Capability is not about theoretical performance. Capability is about what aircraft actually do operationally. An aircraft that cost half as much per hour to operate do twice as much with identical budgets. The pilot perspective specifically matters for understanding operational effectiveness. Swedish pilots transitioning to Gripen from earlier fighters report the aircraft is intuitive, responsive, and pilot-centered in design philosophy. The aircraft emphasizes pilot situational awareness and decision authority, rather than automating pilot out of the decision loop. For a Nordic Air Force tradition that emphasizes pilot quality and initiative, this design approach aligns with operational culture. F-35, by contrast, emphasizes sensor fusion and systems automation, where the aircraft presents processed information to pilots rather than raw sensor data. The philosophy works well for pilots trained in American systems and doctrine. It works less well for air forces with different traditions and training pipelines. The aircraft that pilots trust and feel comfortable operating performs better in actual combat than theoretically superior systems that pilots struggle integrating into their decision processes. The interoperability dimension specifically addresses the argument that NATO standardization requires American systems. Gripen is fully NATO compatible. Link 16 data links work seamlessly with allied systems. Standard NATO weapons integrate without modification. Operational procedures align with NATO doctrine. Swedish Gripen squadrons participate regularly in NATO exercises and demonstrate complete interoperability with American, British, German, and other allied forces. The argument that only American aircraft provide NATO interoperability is simply false. It is procurement protectionism disguised as technical requirement. Any modern Western fighter designed to NATO standards achieves effective interoperability. The question is not whether non-American aircraft can work with NATO forces. The question is whether NATO nations want accepting American procurement monopoly or prefer choosing systems that better match their specific requirements while maintaining Allied cooperation. The Arctic geography specifically explains why Sweden's experience matters enormously for NATO planning. Swedish Air Force has defended Arctic and subarctic territory against Russian air activity for decades. The operational experience base is extensive and directly applicable to NATO northern defense requirements. Swedish pilots know what works in that environment. Swedish maintainers know what fails and what endures. Swedish planners know what infrastructure suffices and what proves inadequate. This knowledge, gained through sustained operations rather than brief exercises or theoretical studies, is now NATO's knowledge, because Sweden is now NATO. And the aircraft that knowledge was built around is Gripen, not F-35. The alliance gained operational expertise that contradicts assumptions American defense planning was built upon. The contradiction is becoming increasingly visible as NATO seriously plans Arctic defense rather than treating it as secondary theater. The political calculation specifically affects procurement decisions across NATO's northern members. Finland joined NATO and operates F-18 Hornets, requiring replacement within a decade. Norway operates F-35, but may consider mixed fleet concepts for missions where F-35 capability exceeds requirements, while costs constrain numbers. Denmark evaluates future fighter needs beyond current F-35 orders. Iceland has no fighters but contributes to Nordic defense cooperation. Each nation now observes Swedish Gripen operational performance in NATO exercises and Arctic missions. The demonstration is not marketing material or contractor promises. It is Allied aircraft flying actual missions in the environment where these nations must defend their territories. If Gripen proves operationally superior for Arctic missions while costing dramatically less, the procurement logic favoring continued automatic F-35 purchase collapses. The industrial participation dimension specifically matters for European NATO members seeking to maintain defense industrial base. Gripen production and support involves multiple European companies with technology sharing and work share that creates jobs and capability across alliance members. F-35 production concentrates in the United States with limited genuine technology transfer despite offset arrangements. European nations increasingly question why defense spending should flow primarily to American contractors when European aerospace companies can produce capable alternatives while maintaining European technical expertise and industrial capacity. The question becomes more pressing as American political reliability decreases, and European nations recognize they cannot depend indefinitely on Washington for security guarantees. The network effect specifically reinforces the shift as more NATO members consider Gripen. Sweden operates Gripen. Czech Republic has selected Gripen. Brazil, Thailand, and potentially Colombia operate or will operate Gripen. As the operator base expands, collective purchasing power for upgrades increases, regional support networks become more robust, and operational knowledge sharing improves. The positive feedback loop that historically favored American systems through network effects is beginning to work for European alternatives, as enough nations choose platforms like Gripen to create self-sustaining ecosystems. Each additional operator makes the platform more attractive for subsequent purchases through improved support availability and reduced per-unit costs for capability upgrades. The strategic implication specifically is that NATO's most advanced fighter, the one designed to dominate any aerial engagement, proves less suitable than a less expensive European design for the mission NATO increasingly prioritizes. Arctic defense does not require aircraft optimized for penetrating sophisticated air defense networks. It requires aircraft that fly reliably in extreme cold, operate from dispersed locations with minimal infrastructure, engage targets at long range with superior missiles, maintain high availability rates, and cost little enough that nations can afford flying them routinely. Gripen delivers exactly that capability. F-35 delivers different capability optimized for different missions. The sustainability dimension specifically matters for long-term Arctic presence. Continuous patrol operations over years and decades require aircraft that maintainers can keep operational without extraordinary efforts. The Gripen maintenance philosophy emphasizes reliability and ease of repair. Components are designed for accessibility. Diagnostics are straightforward. Common failures have simple fixes that squadron-level maintenance can handle. The F-35 maintenance approach emphasizes performance achieved through complexity. Advanced systems require specialized training to diagnose and repair. Many maintenance actions require contractor support. The supply chain for specialized components can experience delays. Over sustained operations, the simpler aircraft maintains higher availability because fewer things break, and what breaks gets fixed faster, with resources available at squadron level. The training pipeline efficiency specifically affects force generation capacity. Gripen training requires less time transitioning pilots from previous aircraft types. The aircraft is forgiving of pilot errors during training. Students build confidence quickly because the aircraft responds predictably. Simulator training effectively prepares pilots for actual aircraft operations. The total training time from selection to combat-ready pilot runs shorter than more complex aircraft require. For nations needing to expand pilot numbers rapidly in response to increased threat perceptions, the faster training pipeline means operational squadrons receive qualified pilots sooner. The F-35 training pipeline is longer due to systems complexity. More simulator time is required, and transition training takes additional months. The time difference compounds across multiple pilot training classes into years of delayed capability generation. The forward presence deterrence specifically depends on actually flying patrols, rather than maintaining theoretical capability. Potential adversaries observe how often NATO aircraft actually patrol disputed airspace. Infrequent patrols suggest limited capability or unwillingness to maintain presence. Frequent patrols demonstrate capability and commitment. The aircraft that costs half as much per flight hour enables twice the patrol frequency with identical budgets. More patrols mean more intercepts of probing aircraft. More intercepts mean better intelligence about adversary capabilities and intentions. Better intelligence enables more effective defense planning. The operational tempo specifically creates deterrent effect that static capability cannot achieve regardless of how advanced individual aircraft may be theoretically. In procurement, the best aircraft is not the one with highest theoretical performance. The best aircraft is the one that matches the mission requirements the customer actually faces. For NATO Arctic defense, the match increasingly favors Gripen, and the more NATO members observe Swedish operations demonstrating this operationally, rather than theoretically, the harder it becomes maintaining that F-35 represents the only viable choice for Alliance air power. The aircraft that actually performs the mission in the environment where the mission occurs is the aircraft that provides real capability, and in NATO's Arctic, that aircraft is increasingly Gripen, regardless of what American procurement doctrine assumes.